We're diving deep today into a conversation between two people who are really pushing the boundaries of how we think about molecular biology. Get ready to explore this really fascinating idea that the tiny machines we study at the molecular level exhibit a level of intelligence and agency that maybe we haven't fully appreciated. And this might even hint at grander organizing principles that are at play in the universe.
It is fascinating how this conversation really challenges our traditional view of molecules as these passive entities just bouncing around. For those of us who are immersed in the intricacies of molecular biology, it's an invitation to reconsider the very language that we use when we're describing these systems.
Let's unpack that a bit. The conversation highlights some really striking examples. So take kinase motor proteins, for example. They don't simply move along microtubules. They're actually making decisions about where to step. And those decisions are based on, what cargo they're carrying and what the cellular environment is like. It's as if they're actually navigating a complex landscape with a sense of purpose.
Right, and consider chaperone proteins. Their role goes way beyond simple binding. These proteins are actively seeking out misfolded proteins, and then they go about correcting them. It's a level of problem solving that you wouldn't expect from something that we, typically think of as just a simple automaton.
And then there's the remarkable selectivity of nuclear pores. They're
Right.
not just passive barriers. They're intelligently discriminating between thousands of different molecules.
That's right. Some are allowed to pass while others are blocked. And what's really fascinating is that they're achieving this level of filtering without relying on ATP. It's a system of intrinsically disordered proteins that create this selective phase, a mechanism we haven't really been able to replicate in our own designs.
It's almost as though these molecular machines are operating with a level of agency and intelligence that we're only beginning to appreciate. Now, the conversation also goes on to critique the language that we often use in molecular biology,
Yeah.
terms like undergoes conformational change. And the point is that using that kind of language can actually obscure the active decision-making and the problem-solving that these machines are exhibiting.
Absolutely. It's a really important point. By using passive language, we risk overlooking the dynamic and responsive nature of these processes. It's as though the protein itself is assessing its environment and then reconfiguring itself to meet very specific demands.
And this leads to a broader discussion about the limitations of reductionism. Now, reductionism, of course, has been a cornerstone of scientific inquiry. And breaking down these complex systems into their components has obviously yielded incredible insights. But it might also be blinding us to some of the emergent properties and behaviors that arise from the very intricate interplay of those components.
Exactly. And our focus on mechanisms, the nuts and bolts of molecular interactions, if you will, perhaps it's led us to overlook the intelligence and the agency that are operating at the system level.
And a really compelling example that they bring up in this conversation is the evolution of C4 photosynthesis. So this complex adaptation which allows plants to thrive in these very hot, arid environments. Well, it's evolved independently over 60 times in different plant lineages.
And just think about the intricacies involved there. You have multiple coordinated changes across enzymes, cellular structures, metabolic pathways, all happening independently and repeatedly. To suggest that this happens solely through random mutation and natural selection really seems to push the boundaries of probability.
It does raise the question whether there might be some underlying organizing principles at play or even like a solution space that becomes more accessible once a successful adaptation emerges.
Yeah.
Almost as though evolution, once it discovers a solution, makes that solution more readily available for other species to access.
Right, and that's where the conversation takes a truly thought-provoking turn. It challenges us to consider whether intelligence and these organizing principles might actually be fundamental properties of the universe, much like the fields and forces that we readily accept in physics. And if we kind of entertain this idea of a field of universal intelligence, a field that influences the organization and problem-solving capabilities of matter, well, it throws open some really fascinating possibilities.
It certainly challenges the prevailing scientific paradigm, which seeks to explain everything through these reductionist and mechanistic models. But if we readily accept mathematical laws as being fundamental, why not consider the possibility that intelligence or maybe like a drive towards organization could be equally fundamental?
That's a good point. And then the conversation draws this really compelling parallel between the double slit experiment and the challenges that we face when we try to understand molecular agency. Both of them seem to point toward the limitations of this purely mechanistic worldview. And it almost like nudges us towards a more holistic understanding that acknowledges the potential role of consciousness and maybe even non-local information sharing.
That's an intriguing connection.
Yeah.
To clarify for our listeners, could you elaborate a bit on how the observer effect in quantum mechanics, as demonstrated by the double slit experiment, might relate to our discussion about the intelligence that we observe in molecular machines.
Sure. So the double slit experiment famously shows that the act of observation can actually influence the behavior of particles at the quantum level. It suggests that consciousness, or at least the act of measurement, is intertwined with the fabric of reality in ways that we're only just beginning to grasp.
So, if our observation can influence the behavior of particles, could there be a similar interplay between consciousness and the behavior of these molecular machines?
It's a very thought-provoking proposition. The conversation suggests that viewing matter not as these independent particles, but rather as excitations in conscious fields, might actually offer a more complete explanation. An explanation for both quantum phenomena and biological organization.
That's a radical departure from our conventional understanding.
It is, and it challenges our object-oriented cognitive biases, which might be hindering our ability to fully comprehend reality at these very fundamental levels.
And this leads to a really fascinating discussion about the role of entropy. It challenges the traditional view of entropy as being purely destructive, and instead suggests that it might also play this constructive role in creating beneficial distributions and functional order at different scales.
Think about the distribution of gases in our atmosphere, for example. Entropy drives those gases towards a state of uniform distribution, but it's that very uniformity that creates the stable layers that protect life on Earth. Or think about how minerals diffuse through water systems. That's entropy at work. Yet it leads to the distribution of nutrients that sustain ecosystems.
So entropy, which we often associate with disorder and chaos, might actually be a key player in the emergence of these complex systems.
It does seem paradoxical, doesn't it? But perhaps what we're seeing are different types of order coexisting at these different scales, and entropy might be the driving force behind some of them.
It's a good reminder that our traditional notions of order as being static and rigidly structured might need to be expanded. Perhaps true order encompasses a sort of dynamic balance, the ability to adapt and evolve in response to these ever-changing conditions.
Exactly. And this brings us to a rather audacious idea that the conversation explores. This notion that the laws of physics, the very foundation of our scientific understanding, might not be the ultimate cause of everything. Instead, they might be reflections of deeper organizing principles or even expressions of a universal intelligence.
That's a pretty paradigm-shifting concept. So you're suggesting that the laws that we so carefully elucidated don't actually dictate how reality works, but rather they describe how this deeper organizing intelligence manifests itself.
It's one way to reconcile the remarkable effectiveness of our mathematical models with this undeniable feeling that they're still incomplete, that they struggle to account for certain phenomena, particularly those that involve consciousness.
It's as though we've been meticulously studying the brushstrokes of a grand masterpiece, analyzing the techniques, the colors, but overlooking the artist, the creative intelligence that brought the whole work into being.
Precisely. By fixating solely on the mechanisms and the laws that govern them, we might be missing the forest for the trees, overlooking the deeper intelligence that orchestrates the entire cosmic symphony.
This conversation really challenges us to reevaluate some fundamental assumptions about science and our approach to understanding the universe. Are we, in our quest for control and predictability, inadvertently limiting our ability to grasp the true nature of reality?
It's a question worth pondering. This desire to reduce everything to these predictable, controllable laws is so deeply ingrained in the scientific mindset. But what if true understanding requires a more humble approach? One that acknowledges the limitations of our current models and embraces the possibility that intelligence and agency might actually be woven into the very fabric of the universe.
Bringing us back to molecular machines, if we can shed this need to define them purely as mechanical systems, we might finally unlock the secrets to their remarkable abilities.
And that shift in perspective, acknowledging a potential underlying intelligence, could revolutionize not just biology, but also fields like medicine, artificial intelligence, our understanding of consciousness itself. It opens up this whole new chapter in how we interact with and learn from the universe around us.
So as we kind of wrap up our exploration of molecular machines and this really intriguing concept of a universal intelligence, let's take a moment to reflect on the potential implications of this paradigm shift, for scientific inquiry itself.
I think this conversation has really highlighted the interconnectedness of fields that, traditionally we viewed as separate. Molecular biology, quantum physics, even consciousness studies, it seems like they're all converging towards a more holistic understanding of the universe.
It suggests that the intelligence that we observe in these molecular machines might actually be just a glimpse into a deeper, more pervasive intelligence that operates at multiple scales.
And this perspective has the potential to really transform how we approach science and technology. Imagine a future where we move beyond simply controlling and manipulating nature, a future where we're actually collaborating with the inherent intelligence of biological systems.
Instead of seeing ourselves as, the sole proprietors of intelligence, we might start to recognize ourselves as participants in this grand symphony of intelligence that permeates the entire cosmos.
It's a very humbling thought, recognizing that we're part of something much larger than ourselves, participants in this cosmic dance of intelligence that's been unfolding for billions of years.
I think that's a really powerful takeaway from this deep dive. As we continue to probe the mysteries of molecular machines and the universe that they inhabit, let's keep in mind this possibility that intelligence, far from being a human invention, might actually be woven into the very fabric of reality.
So as you all return to your labs and your research, consider how this new perspective might inform your work. What might you discover if you approach these molecular machines not just as these intricate mechanisms, but as expressions of a deeper intelligence?
And for those of us who are ready to embrace a new scientific paradigm, one that acknowledges the intelligence that's inherent in the universe, the journey of exploration has just begun. Keep questioning, keep exploring, and let's see where this fascinating path leads us.